Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Advanced Reinforcement Learning, Deep Q Learning and Policy Gradients. Imagine you're teaching a puppy a new trick. Like, sit. You don't tell it how to sit step by step. Instead, you wait for it to accidentally sit, then immediately give it a treat. Over time, the puppy learns that sitting leads to treats. That's essentially reinforcement learning. RL. For I, our AI agent. The puppy tries actions in an environment. The living room gets rewards, treats, or sometimes punishments. No treat, and learns a policy. The trick to maximize its rewards. Our goal as developers is to build this smart agent. Before deep Q learning, there was just Q learning. Think of it like your AI building a giant cheat sheet or a scorecard. For every possible situation it might find itself in, e.g., enemy is far away, health is low, and for every action it could take, e.g., attack, run away, heal, it tries to figure out a Q value, a predicted score of how good that action will be for its long-term rewards. As developers, we'd initially store these Q values in a big table, like an Excel sheet. The AI tries actions, gets rewards, and updates its cheat sheet to reflect better predictions. What happens if our game world, or the number of situations, is absolutely huge? Our cheat sheet table would become impossibly big. This is where deep comes in. Instead of storing every single Q value in a table, we teach a deep neural network, our AI's brain, to predict the Q values. Analogy. Instead of memorizing every single fact, a smart person learns how to reason and figure out the answer. As developers, we'd use libraries like TensorFlow or PyTorch to build a neural network. We feed it a description of the current situation, like pixels from a game screen, and it outputs the Q values for all possible actions. This makes our AI much more scalable and intelligent. Deep Q learning is great for making decisions based on predicted value. But what if we want our AI to learn a direct strategy? Imagine coaching a robot soccer player. Instead of telling it, if the ball is here, and you are there, the value of kicking is X, we want it to learn. In this situation, I should kick the ball with 70% probability, or pass with 30%. This is what policy gradients do. Our AI learns a policy, a direct mapping from situations to actions, or probabilities of actions. It's less about knowing the asterisk value of an action and more about directly knowing what to do. How does the AI learn this strategy or policy? Again, we use a neural network. This time, the neural network directly outputs the asterisk probabilities of taking each action given the current situation. If the AI takes an action that leads to a good reward, we gradient ascent the policy, meaning we tweak the neural network's internal settings slightly, so that it's more likely to take that good action next time it's in a similar situation. If the action leads to a bad reward, we make it less likely. It's like subtly adjusting the knobs on a complex machine to get a better output. As developers, we're building and training this probability-generating neural network. So, when should you use deep Q learning? DQN. And when policy gradients? DQN. Value-based. Great when your AI has a limited, distinct set of actions, e.g., move up, move down, jump. It tries to find the best action by predicting its long-term value. Policy gradients. Policy-based. Excellent for environments where actions are continuous, e.g., turn steering wheel by 15.3 degrees, apply 0.7 throttle. Or when you need to learn a more complex, expressive strategy, they can also be more stable in certain complex scenarios. Think of DQN as learning to pick the best dish from a menu with prices, values, and policy gradients as learning to cook a dish from scratch using a recipe. Policy. As developers, you now have the conceptual tools to understand two powerful approaches in advanced RL. Your next step is to get hands-on. Libraries. Explore frameworks like OpenAI Gym. For environments, stable baselines 3, pre-built RL algorithms, TensorFlow, and PyTorch. Practice. Start with simple environments, like cart pole or lunar lander in Gym, and try implementing a basic Q-learning agent, then perhaps a DQN, and then a policy gradient agent like Reinforce. Focus. Understand how to define your environment's states, actions, and rewards. This is crucial for any RL project. The world of AI is your playground. Go build some intelligent agents. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.